I have 4 more examples I want to work through of changing of the basic period. And then we also have some thrown in some changing of amplitude and maybe some vertical shifting here as well. So this is going to be a smattering of all the various ways we can change this function and the kinds of things I'm going to ask of you. Now, it's possible to make these extremely complicated where there's a change of amplitude and a vertical shift and a horizontal change and you can make so many of these it just becomes a marathon. What I'm going to do is make sure you know how to handle what happens if you have a change of amplitude, or you know how to handle if you have a vertical shift or a change of argument, change of the basic period. I don't need to give you the most impossible problem in the world to figure that out. In fact, that's almost, from my side of the camera, that's counterproductive. I'm going to maybe give you 2. So this has something going on changing the period and also changes the amplitude. This has a vertical shift and it has a changing of the basic period. Now this actually has 3 things going on here. Do you see that? We've changed the basic period, we've changed the amplitude, and we have a vertical shift. So this is easily as difficult an item as I would expect of you. This has a change of amplitude and a change of the basic period. Typically, I would give you at most, anything I would give you on an exam, typically I would give you at most 2 changes because I want to make sure that I can tell that you're doing the work correctly. And if there's a mistake, I want to be able to know, okay, this is the mistake you made, but all the rest of this has been done correctly. So from my perspective, I don't like to give these incredibly huge problematic things where it just takes an hour and a half to work out one graph, because I don't think it's productive from my side of the camera, and I certainly don't think it's productive to help you understand the concept. And so that's going to be my plan. So what we'll do here is just without a whole lot of exposition and a whole lot of explanation, I'm just going to work through these 4 examples on this video. If you like, what you could do is pause the video now, or pause after any individual one and see if you can work the rest of them the way out. So maybe a good thing to do now is to pause and just see if you can draw all these 4 out. And then as I go through the work, make sure that my work is matching what you have to make sure that I'm doing it correctly. So I'm going to work on these 4, and I'm going to call that sort of a lesson. All right, so see if we're back. This is A. And we're doing f of x. I may have to save my board space here, so I'm going to be a little bit cautious here. This is 2 cosine of, what do I have here? X plus pi over 2. And we're going to go through our same basic steps here, right? Close my parenthesis. The same basic steps. So what is the basic shape? Basic shape is the positive cosine. Positive cosine looks like this. What is the amplitude? The amplitude is the absolute value. Make sure you include the absolute value. If you wish to simplify, that's wonderful. If you don't, that's fine too. The amplitude is 2. It's actually the absolute value of 2. And then we have any vertical shifting. Vertical shift, let me write vertical. Is there any vertical shifting here? No, we are adding or subtracting, but this is inside the primary function. There's no adding or subtracting outside the function, and so there is none. So the axis of the graph, the main line axis of the graph is still going to be the x-axis. But then we do have a change. We do have a change of the basic interval. And again, let's do this. We're going to take this expression and put it between 0 less than or equal to, copy, paste. Copy this expression, paste it here, x plus pi over 2, which is less than 2 pi. And then solve for x in the middle. In this case, we need to subtract pi over 2 from all 3 places. So we need to subtract pi over 2 here. We need to subtract pi over 2 here and subtract pi over 2 here. Well, this is easy. 0 minus pi over 2 is negative pi over 2. That's straightforward. Here, this cancels. That's straightforward. This is a little bit more dicey. So you might want to go to the side. If this is not obvious, then we can think of this as 4 pi over 2 minus 1 pi over 2. And now I hope that is clear. That is 3 pi over 2. And so the interval is going to be from negative pi over 2 to 3 pi over 2. So let's see if we can draw this graph. Again, the basic shape, there is no vertical, excuse me, there is no vertical shift. And so what we have here, here's the axis of the graph. The amplitude is 2, so I'm going to go up 1, 2, down, -1, -2. So this is the peak line. This is the trough line. Now I am going to need a little negative space here because I actually do bleed over here into the negative pi over 2. So if this is 1, now I'm going to score off my x-axis. This is 1, so there's 1, 1, 2, 3, and a little more, there's pi. Which means if that's pi, there's 2 pi. And I don't actually need to go that far because here's pi over 2, here's 3 pi over 2, and that actually is my right sideline. Whereas the left sideline, I think I need to go back over here into negative pi over 2. And so the rectangle of the graph extends over to the negative side of the axis. This is negative pi over 2. My picture's getting a little mixed up. Negative pi over 2. And so I do have this divided into 4 equal pieces. 1 at 0, 1, 2, 3, 4. So I do have 4 equal intervals. And so now I need to make my 5 basic points. Peak, node, trough, node, peak. So I start peak, node, trough, node, peak. Play connect the dots, make a nice smooth curve. If the curve misses the dot, just make the dot bigger. And that's the graph of my function. So a picture to that effect would be the kind of thing I'm looking for. All right, so there's example A. Next up, let's play next item in line. Our function is -4 minus sine of x minus pi. And again, go through the same 4 basic steps. All right, so basic shape. The basic shape is, this is sine, but it's a negative sine. So the basic shape is a negative sine graph. What is the amplitude? It's not the -4, it's the coefficient here. This is actually -1. Yeah. So absolute -1, if you prefer, that's 1. There actually is a vertical shift. The vertical shift is down 4 because we're adding a -4. Right, so we're going to shift down. I'll actually write the word down. Right? So the axis of the graph has been shifted down 4 units. The axis of the graph, everything in the picture is shifted down 4 units. And then we have the basic interval. And so we take this argument and put it between 0 less than or equal to x minus pi, which is less than 2 pi. And then solve for x in the middle, which means you add pi here. Everybody gets add pi, add pi, add pi, add pi. So I got pi is less than x. This cancels, which is less than 3 pi. So the interval I'm going to graph over is from pi to 3 pi. All right, I'm going to shift this down, so I'm going to look ahead on my graph here, put my graph way up higher here. So this is the main axis. However, we got to shift down 4 units, 1, 2, 3, 4. So we're at -4 is now the central axis of the graph. All right, the amplitude is 1. So the peak line is up at -3. The trough line is down at -5. Peak line at -3. Trough line at -5. And now make the horizontal axis. This is 3, so that's 3, and a little more makes pi. See how I did that? There's 3. Translate, that's 3. Just use your hand, or I'm using my hand like a compass. So that's 3, so that's 3. That's a little bit more is pi. If that's 1 pi, that's about 2 pi. But I need to go all the way over to 3 pi. So I need one more here. And this is the top, this is the bottom. But the sides are at pi, so here's one edge, and the other side line is over here at 3 pi. All right? So this picture needs to go into that box, and I need to divide this into 4 equal pieces. Well, it's divided into half. I need to divide that into halves. Well, this is pi over 2, which I don't need. This is 3 pi over 2. These are the odds. 1/2, 3 halves, 5 halves. If I were to need it, 7 halves, right? 1/2, 3 halves, 5 halves, 7 halves. They're the odd halves. And now I need to make node, trough, node, peak, node. Node, trough, node, peak, node. And then connect the dots. And within the limits of my badly drawn picture, that is 1 period of that graph. I will always ask you to draw 1 period of the graph. The text may ask you to draw 2 periods. I will always ask you to draw 1 period and just go from the standard period. Now, let's pretend you're actually doing this problem from the textbook. The textbook might be asking you to draw 2 periods, and if that's the case, then one thing you could do is simply just take this and copy and paste it over here. The other version would be this. If you want to do 2 periods, you go all the way to 4 pi. Instead of 2 pi, you go 4 pi. And now this is going to be 2 periods. Put x minus pi in here. Add the pi across. Now this is pi. Is less than or equal to. This cancels. Is less than, you add pi here, it's 5 pi. So you could go from pi to 5 pi and make another copy of this. All right. I will ask you just to make 1 period. If you're doing the homework, just do 1 period is fine. Just do the standard period change. But for the record, that's how you would do multiple periods if that were desired. All right. So there's graph B. All right. So how are we doing here? C, same song, next stanza. So this is This is C, and this is f of x, and we have 3 minus 2 cosine of 2x, right? So just go through the same procedure. Once you have this procedure down, everything is the same of same. The basic shape, right? Basic shape is cosine, but it's negative cosine, right? This is a negative cosine. We see that, negative cosine. So upside down cosine is the little hill. Looks like a hill instead of the valley. And then we have the amplitude. Yes, the amplitude is now absolute value of this coefficient, absolute value of -2, which is 2 if you prefer. And there actually is a vertical shift. Yes, there is a vertical shift. The vertical shift is up 3. This is a positive 3. And so we shift up 3. So we go up 3, and the amplitude is 2. So we have shifted the axis of the curve. And so in a sense, and now we need the change in the basic interval, right? So every time these 4 steps, it'll get you through anything you're going to be asked. Anything you're going to be asked, these will get through. The basic interval, we'll go down here. This is 0 is less than or equal to. Copy this expression and paste. And now that's why if there's nothing here, then the basic interval is just going to be 0 to 2 pi, and there's nothing to do. So this is the standard interval. But if there is a multiplier, in this case, or adding or subtracting, any change to this argument gets placed here, and now solve for x. In this case, everything is divided by 2. divide by 2, divide by 2, divide by 2. And so 0 is now less than or equal to, the 2's cancel. X is less than or equal to, less than. The 2's cancel again, pi. So this goes through one complete cycle from 0 to pi. All right? So let's see, here's my graph. I need a vertical shift of 3. 1, 2, 3. And that is now the axis of the graph. That is now the axis of the graph. That's the center axis of the graph. The amplitude is up and down 2. 1, 2, so there's 5. 1, 2, so there's 1. The peak line is at 5. The trough line is at 1. So far, so good. So we've taken that into account. We've taken that into account. We have our basic shape, but we need the basic interval here too. The basic interval, the sides of that box go from 0 to pi. So let's get our horizontal axis here. This is 3. So there's 3, and a little more makes pi. But that's it. That is the extent. We need to take this interval and divide it into 4 equal pieces. Well, we know how to do that. If this is 1 pi, then we divide this into 4 pieces. This is pi over 2. This is pi over 4. 1/4, 2/4. That's not hard to figure. So as soon as you get half of that is a fourth, and then 1/4, 2/4, 3/4. Do we follow that? Let's do that one more time. We mark out pi because that's 3 and a little bit more makes pi. Then we divide this into 4 equal pieces. This is pi. So there's pi over 2, which means this is pi over 4. But now that we have that, 1/4, 2/4, 3/4, and we have our values. Next is just put 1, 2, 3, 4, 5 basic points in place. Trough, node, peak, node, trough. So we start at trough, node, it's going to be very slender, peak, node, trough. And so that's the basic sketch of our graph. All right, one more and we'll be finished here. Here we have it. Okay, so d delta, let's see, this is f of x is 3 sine of 2x plus pi. This has got a little bit more going on over here. All right, so what do we have? We have basic shape. Basic shape is a positive sine curve. Amplitude. Absolute value of 3, which is 3 if you like. All right, vertical shift. Excuse me, vertical shift. There is no vertical shift. We've not added anything outside the main function, so there is none. So the x-axis is still the axis of the function. And then we have the basic interval. And again, we take 2x plus pi and put it in the middle of 0 and 2 pi. So that should be straightforward. Now the next piece is, let's see what we got here. We have solve for x in the middle. So I'm going to subtract pi from all 3 places. Subtract pi, subtract pi, subtract pi. Leaving negative pi is less than 2x, these cancel, is less than, this is or equal to, is less than pi. And now divide everything by 2. So that gives negative pi over 2, less than or equal to x, is less than pi over 2. So we have all the bits and pieces. Now the question is, can we throw them all together here? So we have, there is no vertical shift, so the axis, emphasize. Now see how I've done? Anytime the dotted lines go on the x-axis or the y-axis, kind of make them a little diagonal and it'll show up better. So there's the axis of the function. The amplitude is 3, so we need to go up 1, 2, 3 for the peak line, and down -1, 2, -3 for the trough line. We do need to go backwards over here to -π/2, so I'm going to go ahead and throw some of this over on the negative side of the picture here. All right. And now I need to put this horizontal axis. See, we don't have the interval yet, so the horizontal axis, let's see, this is the scale, so there's 3. So there's about 3, which is, and a little more, that makes pi. But we're only going from -π/2 to π/2. So if this is pi, you can put 2 pi out here, but we don't need it. All we need is π/2, and we know that's the right-hand side. And then we also need -π/2, so that same distance over here. This is -π/2. There's the left-hand side. I need to divide this into 4 equal pieces. This is +π/2, this is -π/2, and we know how to divide each of those into half. This is π/4, and this is -π/4, and 1, 2, 3, 4. We have now 4 equal pieces. Now place those 5 basic points into that little box, and we're off to the races. Node, peak, node, trough, node. Node, peak, node, trough, node, and then connect the dots. And they couldn't be simpler unless it actually were simpler. I'm going to make my dot bigger because I missed the curve here. All right. So I think that gives us a pretty good smattering of the kinds of things I'm going to be asking of you. And if you practice these and you practice the ones in the homework, you should be up to speed and able to do anything I'm going to be asking of you.